Hello everyone, welcome back to our channel. In today's video, we will be discussing a new lesson. Now our new topic today would be multiplying and dividing rational expressions as well as complex fractions. Now the concept of rational expressions has been clearly discussed by our previous video, as well as adding and subtracting rational expressions, both similar and dissimilar expressions. Now let's proceed to, we're gonna focus our attention now with multiplying and dividing rational expressions. So let's have a short recap about the concept of rational expression. Now in mathematics, a rational function is any function which can be written as the ratio of two polynomial functions. So considering we have here an example, x squared plus 5 as our numerator and x plus 2 as our denominator. Now, it is a rational expression because it is a ratio of two polynomials. I know you're very expert on identifying as to whether or not an expression is a rational expression or not. Okay, because it has been clearly discussed in our previous video. Then, since they are fractions, let's take a look at this one. Simplify a rational expression. To start with, let's try to have this example first. If we are asked to simplify a rational expression given 3y times the quantity of y plus 7 over y plus 7 times y squared minus 9. All we have to do is divide the same expression from numerator and denominator, since the expression here, since it is a rational expression and we are only asked to simplify. So all we have to do is divide the same expression from numerator and denominator, and there exists a common factor between our numerator and denominator, which is y plus 7. So we are going to cancel out y plus 7 on our numerator and y plus 7 on our denominator. Then what remains is 3y over y squared minus 9. So it's just a short review on how we simplify a rational expression. Now what about this one? There are actually numbers that will not work in rational expression. Since we also discussed on how to get the solutions on rational expressions. Now in this case, let's just have a recall on these certain numbers that would not work in this rational expression. What do you think? You have there, they are negative 7, positive 3, and negative 3. It is said that these are numbers that will not work in this rational expression, and so they are called extraneous solutions, because the moment you are going to substitute the values of our y, such as negative 3, positive 3, and negative 7, into this original equation, it will make the original equation undefined. Okay, the denominator will be equal to 0. So that is why we have here, if we have that, if you're going to factor out the denominator, so you have y plus 7, y minus 3, and y plus 7. So can you see why negative 7, 3, and negative 3 do not work as answers? It is because it will make the whole expression undefined. Okay. So we are going to, these are just examples of specific integers or values of our variable in a particular rational expression that will make the denominator 0, and we call it excluded values. Now, let us simplify this one. Assume the denominator cannot equal to 0. If we have a to the power of 4b minus 2a to the power of 4, 2a cubed minus a cubed b. So what are we going to do in simplifying this one? So we have, okay, so we have here, we are going to get the common monomial factor on our numerator as well as our denominator. Now, a to the power of 4b minus 2a to the power of 4, our common monomial factor between a to the power of 4b minus 2a to the power of 4 is a to the power of 4. Okay? And our common monomial factor in our denominator, we have 2a cubed minus a cubed b is a cubed. So that is our common monomial factor. Since our numerator, both our numerator and denominators are binomials, and then we just simply extract the common monomial factor. Since we have here in our numerator a to the power of 4 is our common monomial factor, then our factored form in our numerator would be a to the power of 4b divided by a to the power of 4, that leaves us b. Okay? Then negative 2a to the power of 4 divided by a to the power of 4, we have negative 2. That is why our factors in numerator would be a to the power of 4 times b minus 2. Same procedure for our denominator. The common monomial factor exists in 2a cubed, and a cubed b is a cubed. So 2a cubed divided by a cubed, that leaves us 2. Then negative a cubed b divided by a cubed, we have negative b. That is why our factors for denominator is a cubed times the quantity of 2 minus b. Okay. The next thing that we're going to do, we have here, okay, for a moment, we have to, what have you noticed with the one enclosed in parentheses? You have here 2 minus b, you also have, we have b minus 2 in the numerator, and we have 2 minus b in our denominator. So, for us to cancel out our b minus 2 and 2 minus b, we are going to multiply negative sign on our numerator. We have to make sure that our denominator will have a positive sign. So we have, our new numerator now would be negative a to the power of 4 times 2 minus b over a to the power of 3, or a cubed, times 2 minus b. Now, our sign now in our binomial, the one enclosed in parentheses, both our numerator and denominators are the same. So we have here, we have a to the power of 4, b minus 2 over a cubed 2 minus b. Since we multiplied negative a to the power of 4, we cancel out 2 minus b, and on our numerator and denominators, we are left with negative a to the power of 4 divided by a cube. And remember the loss of exponents, our final answer will be negative a. Because our loss of exponents states that we need to just simply subtract the exponents of our denominator from our numerator. So the answer is negative a. Okay, let's proceed to the next. So we're still on simplifying. Now this time, what about if we are multiplying the fractions? Now this time, let's deal with numbers. Like we do the simplest form. if we have 12 divided by 7 times 5 over 3. So we are going to, if we have that one, we can actually multiply straight across, like both numerators, both denominators, or we can actually do the shortcut one, where we are going to get the LCD, not LCD, but the common factor. So we will be dealing with smaller values of numbers. Then in this case, we just simply multiply straight across. So if you have 12 and 5 as our numerator, just simply get the product. That is 12 times 5, that gives us 60. Then 7 times 3, that gives us 21. Then between 60 and 21, our GCF, or the greatest common factor, is 3. So 60 is divisible by 3 and 21 is divisible by 3. Therefore, we have our simplest form is 20 over 7. Okay. Now, what happened here? If you have 20 over 7, you could also have the other way around. Like what I have told you a while ago, we can actually get the greatest common factor first, or just cancel out without multiplying the given large values of numbers, both numerators and both denominators. So for 12 and 3, there exists a GCF, or greatest common factor, is 3. That is 12 divided by 3, that gives us 4, and 3 divided by 3, that gives us 1. Okay, that is why we have this expression 4 over 7 times 5 over 1. Then after which, we can proceed to multiplication, multiply both numerators and multiply both denominators. So you have 4 times 5 is 20, 7 times 1 is 7. So you still get the same result, and it's up to you which one you're going to, which process you're going to use. Okay. Now at this point, we will be, now let's proceed to multiply the fractions. Now reduce before multiply. We have here 8x divided by 21y cubed times 7y squared over 16x cubed. Now we can reduce first before we proceed to multiplication on both numerators and denominators. So we will be dealing with smaller values. So in this case, between 8 and 16, there exists a greatest common factor, which is 8. So between 8x and 16x cubed, the greatest common factor is 8x. So we have 8x divided by 8x, that gives us 1. Now look at the 1 at the last line. We have here 1 as the numerator. And then 16x cubed divided by 8x, that gives us 2x squared. Okay, we're able to follow? And then let's proceed to the denominator of the second rational expression and the denominator of the first. We have 7y squared and 21y cubed. The greatest common factor exists is 7y squared. So 7y squared divided by itself is 1. And then 21y cubed divided by 7y squared, that gives us 2x squared. Therefore, we have here, go back to the process. We have 1 times 1, meaning multiplying both the numerators. That is 1, and then 3y times 2x squared, that gives us 6x squared y. That is our final answer. Okay, what about this one? Reduce before multiply. Okay, so we have here 5a to the power of 4c over 12b times 24bc squared over 15a cubed b squared. So we are going to look for the greatest common factor between our numerator and denominators. Okay, therefore we have here between 5a cubed, the numerator of our first rational expression is 5a cubed c. And our denominator of the second expression is 15a cubed b squared. And the greatest, the GCF or the greatest common factor is 5a cubed c, not c. You have 5a cubed, that's it, 5a cubed. Then we have here 5a to the power of 4c divided by 5a cubed. That gives us ac. Okay? You look at the one at the bottom, the expression. Our AC there is the numerator. Now let's proceed to the denominator of the second expression. We have 15a cubed b squared divided by the GCF, which is 5a cubed. That gives us 3b squared. Okay, I hope you were able to follow. Now, between the denominator of the first expression, you have 12b and 24bc squared. Let's try to examine the GCF. What would be the GCF? Remember, 12 and 24 can be divided both by 12. That is our greatest common factor between 12 and 24. Then we have also common variable, which is b. Therefore, our greatest common factor between 12b and 24bc squared will be 12b. Okay? Therefore, 12b divided by 12b is 1. So we have 1 as the denominator of the first rational expression. Then 24bc squared divided by 12b, we have 2c squared. Okay? So we now have our new expressions AC over 1 times 2c squared over 3b squared. So it's easier for us if we reduce before we multiply. So we are dealing again with smaller values. So we have AC times 2c squared, you have 2ac cubed. Then 1 times 3b squared, you have 3b squared. So our simplified form is 2ac cubed over 3b squared. That is our product between the two expressions, rational expressions. Now, what about if we have k minus 3 over k plus 1 times 1 minus k squared over k squared minus 4k plus 3? Okay, there are expressions that we can factor out. So, k minus 3, copy, then k plus 1, that is our k minus 3 and k plus 1, that is our first rational expression. That's already in simplest form, so no need to factor out. But 1 minus k squared can be factored out. Can be factored out, I mean. So you have, if we're going to put negative outside the grouping symbol 1 minus k squared, that will give us k squared minus 1. That is actually the difference of two squares. So we put the negative sign outside the k squared minus 1. So there are still factors that we can cancel out from the denominator. Then k squared minus 4k plus 3 is a trinomial whose factors are k minus 3 and k minus 1. Okay? So we can now multiply. We can cancel out before we proceed to multiplying the greatest common factor or from both numerator and denominators. So k minus 3 can be cancelled out. Then we have, okay, we can still expand k squared minus 1 before we proceed to cancelling or cancellation. We copy first k minus 3 over k plus 1 times negative our k squared minus 1. It is a difference of two perfect squares. We have, the difference of two squares. So that can be factored out with k plus 1 and k minus 1 over We just copy k minus 3 and k minus 1. So we have k minus 3 can be cancelled out. Then k minus 1 also can be cancelled out, as well as k plus 1. Now what remains is 1 over 1 times negative 1 over 1. Therefore, our answer is negative 1. Okay. Now, what is the difference of division and multiply of fractions? Or dividing and multiplying of fractions? So, if you can still remember the difference when we were still dealing with just numbers or integers during our elementary years, we have here 2 over 7, for example, divided by 3 over 4. All we have to do is, we have here, when dividing, you multiply by the inverse of the second fraction. Or just simply get the reciprocal of the divisor, then proceed to multiplication. So our dividend is 2 over 7, and our divisor is 3 over 4. We're going to get the reciprocal, okay? Or the inverse of 3 over 4, that's 4 over 3. Then proceed to multiplication. That is why we have 2 over 7 times 4 over 3 is equal to, you multiply both numerators, you have 2 times 4, you have 8, and 7 times 3, you have 21. Okay? So it's very simple. Just get the reciprocal of the divisor and then proceed to multiplication. Okay, let's proceed. Okay. What about this expression? You can apply reduce when multiplying. You have 10px squared over 3c squared d divided by 5px over 6c squared d squared. So we have here 10px squared over 3c squared d. We are going to get the reciprocal of our divisor. We have 6c squared d squared or all over 5px is equal to, okay, we are going to identify again our greatest common factor that exists in both numerators and our denominators. So for 10px squared and 5px, our greatest common factor is 5px. Therefore, we have 10px squared divided by 5px, we have 2x. Then 5px divided by 5px is 1. Okay? Then between 3c squared d and 6c squared d squared, our GCF is 3c squared d. So 3c squared d divided by itself is 1. Then 6c squared d squared divided by 3c squared d is 2d. Then we're going to multiply both our numerators and both our denominators. You have 2x times 2d. You have 4dx, and 1 times 1, of course, 1. Our final answer is 4dx. Okay, next. Now, what about complex fraction? Now, a fraction with fractions in the numerator or denominator. We call it fractions if there's a fraction with fractions in the numerator or denominator. For instance, you have 1/3 divided by 5 over 7. Okay. So in this case, you have 1/3 divided by 5 over 7. It's just the same process, like 1 over 3 divided by 5 over 7. You copy the dividend 1/3. And then you just get the reciprocal of the divisor, which is 5 over 7. That becomes 7 over 5. Then proceed to multiplication. So you have 1 times 7 is 7. And 3 times 5 is 15. Okay. Now, how are we going to simplify the complex fraction? Remember, the fractions are division statements. Okay. So considering we have x squared over 9x squared minus 4y squared divided by x cubed over 2y minus 3x. So what are we going to do now is, we're going to express it in this way. You have x squared over 9x squared minus 4y squared. divided by x cubed over 2y minus 3x. The first step, since we are dividing rational expressions, we're just going to copy first the dividend. Then we're going to get the reciprocal of our divisor. That gives us 2y minus 3x over x cubed. Okay? And then we proceed to multiplication. After that, we're going to reduce. Okay? In reducing, we have there, or we can just simply, we're going to factor out first if there are expressions that are still factorable. Now our numerator, our first rational expression or our dividend is x squared divided by 9x squared minus 4y squared is a difference between two squares. So you have 9x squared minus 4y squared. That can be factored out by 3x plus 2y and 3x minus 2y. Then we extract the negative 1, we multiply negative 1 of our 2y minus 3x to make it 3x minus 2y. So we can cancel out later on a common factor with our denominator and our first rational expression. Then just copy x cubed. Okay? Then the next thing would be, okay, so we can cancel out 3x minus 2y. And then between x squared and x cubed, our common factor is x squared. So that is x squared divided by x squared, that is 1. That is why we have our numerator, which is 1. And then, since our 3x minus 2y has been cancelled out already, both our numerator and the second expression and denominator of our first rational expression. And then we have x cubed divided by x squared, that is x. Okay? So what remains now, we have 1 over 3x plus 2y times negative 1 over x. So let us proceed to multiplying across. Let's multiply both numerators. You have 1 times negative 1, that's negative 1. Then multiply 3x plus 2y times x. We have x times the quantity of 3x plus 2y. Okay, that's it. I hope that everything is clear. Now this time we will have an assessment. Now in your assessment, first part is you'll start number 7 because the numbers from 1 to 6 are just very simple. So we just have number 7 to 14. So I will going to read all. So we have number 7, you have 6 times r plus 2 over 20 times 4r over 6 times r plus 2. Number 8, you have 7n squared times n plus 4 over n minus 3 times n plus 4 times, you have n minus 3 over n plus 8 times n plus 6. Number 9, we have 2 times the quantity of p plus 6 over 4, then times p minus 3 over 2 times p minus 3. Number 10, you have 9 times the quantity of r plus 4 over r plus 4 times 9r over 9y minus 5. Okay. Then number 11, we have 8 times m plus 1 over 7m times 9 over 8 times m plus 1. Number 12, we have p plus 6 times p minus 4 over p minus 4 times 1 over p minus 4 times p minus 2. Number 13, we have 1 over v plus 10 times 10v plus 30 over v plus 3. Number 14, 7n over 24n cubed minus 64n squared times 9n minus 24 divided by 7n. Okay, let's proceed to part 2. For part 2, we will have the operation division. Okay, so this is dividing rational expressions. Number 1, you have negative 6x to the power of 4 divided by 3x to the power of 5 divided by 2x squared times the quantity squared over negative 4. Number 2, 3 times the quantity of x minus 1 over y divided by 5 times the quantity of x minus 1 squared over 2y. Number 3, 12x plus 24 divided by 36x minus 36 divided by 6x plus 12 over 8x minus 8. Number 4, y squared minus 16 over y plus 3 divided by y minus 4 over y squared minus 9. Number 5, 4y plus 12 divided over 2y minus 10 divided by y squared minus 9 over y squared minus y minus 20. Number 6, 2m squared minus 5m minus 12 over m squared minus 10m plus 24 divided by 4m squared minus 9 over m squared minus m plus 18. Okay, so I hope that you will be able to answer our assessment part, both part 1 and 2, and that you learned something in today's video. Before I'm going to end this video, let's have a math code. We have here, this is actually dedicated to math lovers out there. So you have math is love, math is life. It's not just a subject or calculations. It's a subject of happiness and satisfaction. So that would be all. And thank you so much. And please don't forget to subscribe our channel. Bye.